Hello guys, welcome to the channel Mathemagix JEE. Let me introduce myself first. I am Orkodeep Das, a BTech UG student from the Department of Aerospace Engineering at IIT Kharagpur. Today, we are going to do a quick revision of the chapter Matrices and Determinants, where we are going to cover the main concepts of mathematics relevant from the point of view of JEE Main. I will link the playlist in the description, and this session onwards, I am changing the format of this revision series a little bit. I am bringing handwritten slides like this. So you can directly use these slides as short notes after I attach PDF copy of this session in the description. So I hope that it will help you better. So let's begin our session. Now this chapter is very much important and scoring from the point of view of JEE Main, because you can see in JEE Main 2024, 41 questions in total were asked from this chapter, 20 in January attempt and rest 21 in April attempt. So you can expect at least two questions from this chapter in your JEE Main paper. And this is a easy chapter and scoring also. So you should not miss this chapter. Let's begin. The first topic we are going to discuss is about matrices. So, what are matrices? Matrices are the arrays of elements with size m by n. So, m is the number of rows and n is the number of columns. And we denote a matrix A by a capital letter, like we named this matrix as A and then define this matrix in terms of elements of this matrix, that are Aij, and the size of the matrix is to be written in the below right corner of this bracket, which is m by n. Now this Aij denote the elements of matrix A, where I is the row number and j is the column number. That means if this element is A11, that means it is in the first row and first column. So columns are like this vertically and rows are like this horizontally. So this is the element of first row and first column. Similarly, you can see this. It is the element which corresponds to first row and the second column. So it is A12. Similarly, you can say that for other elements it is also true. Let's proceed. Now we discuss the types of matrices. So we discussed that the size of matrices is given by m by n. So m is the number of total rows and n is the number of total columns. And we take the case when m is equal to n. So the matrix would look like A equal to Aij n by n, or you can also write it as m by m for this case, because m is equal to n. Then it is called a square matrix of order n, like this. Similarly, when m is 1 and n is something, you say 2, 3, 4 or so on, then this is called a row matrix, or we sometimes call it the row vector. And when n is 1 and m is, let's say, 2, 3, 4 or so on, then we call this case as column matrix. So the examples are given. You can read this part yourself. Now we take the types of square matrices that we need to study. This is very much important. So please keep this whole slide in your mind. Now square matrices mean order of the matrix has to be n by n. So the number of rows must be same as the number of columns. And In this case, when all the elements of the matrix is 0, we call this case as null matrix. Similarly, when Aij, that is the element of this A matrix, is 0 for all I greater than j. Now, you need to put 0 in that part where the number corresponding to the row number is greater than number corresponding to the column number. So this element, we can write this, it will become A21. Now this 2 is I and 1 is j. So I is clearly greater than j. That means this element must be 0. Similarly, these two elements will also be 0. So this matrix becomes an upper triangular matrix. We call this by this special name. So you have to keep this case in your mind. Similarly, when aij equal to 0, for all I less than j, you can simply see that the triangle here that was being formed by the elements will simply get inverted above this diagonal. We call this diagonal as the principal diagonal of a square matrix. We will see about it in the next slide. So you can say that as the triangle gets inverted, in this case, it becomes a lower triangular matrix. Similarly, we can define a case where Aij, that's the element of the matrix A, is some constant k, which is non-zero for I equal to j. That means I equal to j means like A11, A22 or A33. This is for a 3 by 3 matrix. And you should remember that scope of JEE is limited to matrices of order 3 or less than that. So the maximum order of matrices in our syllabus will be 3 by 3. So we will majorly discuss about that only. So here I have given an example of this type of matrix when the diagonal elements will be some non-zero number k and rest of the elements are 0, then this matrix will be called scalar matrix. Now, if in a special case this non-zero constant becomes 1, then we call this matrix as identity matrix. We denote this identity matrix by I with a subscript n. That n denotes the order of the matrix. So if n is 3, that means the matrix is 3 by 3, then we write the identity matrix as I3, which is equal to this matrix 1 1 1 0 0 0. Then the rest of the elements will become 0. So this is called I3. Similarly, you can form I2. Now let us take this case when Aij is Aji for all ij. That means if we interchange the row and the column number, we get the same element. So here, if we put I equal to j, that means Aii should be equal to Aii. That means the diagonal elements will not be affected. And so here you can see that also these diagonal elements are nothing special. But if we say about these two elements, this is element A12 and this is element A21. So A12 and A21 must be same. In this case, both is equal to x. So we call this matrix a symmetric matrix. Similarly, if these two elements that are the mirror image about the principal diagonal of this square matrix are negative of each other. So Aij is basically minus Aji. That means this is the element A12. Similarly, this element is A21. So A12 is negative of A21. In this case, you call it a skew symmetric matrix. Now here you can see an interesting thing. It becomes Aii is equal to minus aii. That means aii becomes 0. So all the diagonal elements of this matrix must be 0. This is what we call a skew symmetric matrix. So you have to remember these definitions clearly. Now coming to this part, principal diagonal is defined by the elements where I is equal to j. These elements correspond to j greater than I, where the column number is greater than row number, and these elements correspond to I greater than j, where the row number is greater than the column number. So keep this thing in your mind. Now here coming to an important point, that is principal diagonal is defined for square matrices only. You can see why. Because if a matrix is like this, let us take the order 2 by 3. So let us take the matrix as some general matrix A, B, C, D, E, F. This is of the size 2 by 3, 2 rows and 3 columns. Then there will be no principal diagonal, because diagonal we define as the connecting line which joins the opposite vertices of this quadrilateral. Of course, the line has to be made by elements only. So in this case, there are no such diagonals possible. That means principal diagonal cannot be defined in the case we just discussed. Now, trace of a square matrix A is defined as trace of A. We denote it by this symbol TR of A, which is defined as the summation of all the diagonal elements. That means if a square matrix 3 by 3 is like this 1 1 0 0 1 0 0 0 0, then the sum of the diagonal elements that lie on the principal diagonal, we define this summation as trace. So trace of this matrix, let us say this is M. So trace of M will become simply 1 plus 1 plus 0, that is 2. So keep these things in your mind. Now coming to an important point that is highly important in the perspective of JEE Main and Advanced, that is PnC mixed with matrices. So PnC stands for permutation and combinations, you know. So PnC mixed with matrices produces many questions. You can see the previous year questions also. Many times permutation and combinations is mixed with matrices to produce great questions. And we will do some practice on this topic in the next slides, and I have provided some PYQs there. I will solve the first question and then you will have to solve the rest of the questions yourself for your practice. So here is the first question. It was asked in JEE Main 2022. Let S is this set and let Tn is this, then the number of elements in the intersection of these 100 sets. You can see this denotes T1 intersection, T2 intersection, T3 intersection, T4 intersection, so on up to intersection T100. We have to find the number of elements in this set. Let us denote this set as S dash. Now S is given to be this. Now what does S means? S means that S contains all the matrices of this form where A and B can take values from the set of first 100 natural numbers. And let Tn, so this set is dependent on the choice of n. So A is a matrix which resides inside the set such that A to the power n into n plus 1 is identity matrix. Now here you can see that if we put n equal to 1 here, it becomes a to the power 2 is I, that is the identity matrix. And if we put n equal to 2, it becomes a to the power 6 is equal to identity matrix. Similarly, you will get always an even natural number as your power. Now this a square is defined as a into a. So we need to find a square first. So a square becomes a into a. So a is of this form as a resides inside the set S. So a square you can calculate by matrix multiplication that we will discuss in the next few slides. But here see this question first. So this becomes 1 plus 0, so 1. Then it becomes ab minus a, and this becomes 0. This becomes b square. Now we have to only analyze this first case, because we know that if a square is I, then a to the power 6 can be written as multiplying a square with itself 3 times. So a to the power 6 will be a square times a square times a square. So this becomes I times I times I. So that means it will be I itself. So if we consider the case a square equal to I only, we will get the corresponding values of a and b such that all the other cases, that is a to the power n into n plus 1 equal to I, will also be satisfied. So a square is I. That means this matrix 1 ab minus a 0 and b square is equal to the second order identity matrix, that is 1 1 0 0. Now if this is equal to I, then we can clearly say b should be equal to 1. And similarly ab minus, so we write it here, ab minus a is equal to 0. That means a into b minus 1 should be 0. As b is 1, a can be anything. So a can be 1, 2, 3, so on up to 100. So a can take all the values that are mentioned in this set. So we have total 100 cases. So A, B, this ordered pair will be 1, 1, then 2, 1, then 3, 1, so on up to 101. So we have total 100 cases for each Tn. Now this T1, if we consider this case, we just calculated, where a square has to be equal to I. This T1 gives us 100 ordered pairs. Now T2 will also give us 100 ordered pairs, but that ordered pairs will be same as the ordered pairs that we just calculated. So for all these cases, there will be also 100 ordered pairs of A and B. And in each case, the ordered pairs A comma B will be the same. That means if we take the intersection of these 100 sets, we will get the same 100 ordered pairs of A comma B. So the number of elements in this intersection sets, that is the set S dash, it will be equal to 100. because all the ordered pairs of A and B are same. So our correct answer in this case will be 100. I hope you understood this question. Now I have given two more questions on this topic, that is mixture of permutation and combination with matrices. Now this is a difficult topic, I know. If you want to skip it, it is no problem. But if your permutation and combination is strong, you can try these questions as revision question. So you have to try it yourselves, all these questions. Now this is the next topic, that is matrix addition or subtraction. So if A and B are two matrices of order m by n and p by q, addition or subtraction is defined if and only if the matrices are of the same size. That means if we want to add these two matrices, let's say the first matrix is of the order 2 by 2, then the second matrix should also be the order 2 by 2. You cannot take this order as 2 by 3 or 3 by 2 or any other order. So this is possible, this is not possible, this is not possible. You have to keep this point in mind. So here is the key thing, that the row number of the total row of the first matrix should be equal to the total rows of the second matrix, and similarly the total columns of the first matrix should be equal to total columns of the second matrix. Here are some examples, you can see yourself. When we add two matrices, we just add the corresponding elements. So A11, that is this element, is to be added to B11, that is this element, it produces 3. Similarly, for the other elements, you will do the same. Let's proceed. Now, coming to matrix multiplication. If A is this matrix and B is this matrix, then product of this matrix P is equal to AB is defined if and only if number of columns in A is number of rows in B. That means if we simplify it, it becomes, let this is a matrix of the size 2 by 3. Then we want to take a product of this matrix with some other matrix. Now the product is only defined if the row number of this matrix is equal to the total number of columns in this matrix. So here it should be equal to 3 to define the product. That means you can take anything here like 1, 2 or 3 or 4 or any other number. But here you have to have the number 3 in this. So this is the thing you have to keep in mind. Now this point is very much important, that in general AB product is not equal to the product BA. So order always matters in the product of two matrices. Now we can also say that product of two matrices A and B is defined. So let us take the case AB is defined. Then BA may or may not be defined. For example, if you take the case 1, 2, 2, 3, this is a 2 by 2 matrix. You simply product it with a matrix of size 2 by 1. Now this 2 by 1 matrix we can take as anything 2, 3, let's say. Then this matrix product is defined. But when we reverse the order of the multiplication, that means 2, 3 here with size 2 by 1, and then 1, 2, 2, 3 with size 2 by 2, then this multiplication is not defined because here is 1 and here is 2. So AB is defined, that doesn't mean that BA should also be defined. You need to keep it in your mind. Here are some examples of matrix multiplication. Now, how is matrix multiplication done? You need to simply go by row to column multiplication. This is the most general way of multiplying two given matrices if their product is defined. You have to simply go from the left side to the right side of this row of the first matrix, first row of the first matrix, and then go in the decreasing order, that is going down the first column of the second matrix. So you product these two elements and then product these two elements. So in this case, you are taking a product of the first row of the first matrix with the first column of the first second matrix. So you are going to have, let's say this matrix is P. So you are obtaining the value of the element of P in the position P11. So when you multiply the first row of the first matrix with the first column of the first second matrix, you basically get the first row and first column element of the product matrix. Similarly, if you multiply the second row of the first matrix with the first column of the second matrix, you get the element of product matrix at the position 2 1. So this is P21. You can simply see it by yourself. Now let's proceed with our discussion. Here is a very interesting point. A square, that is A multiplied by A, is defined if and only if A is a square matrix. This we can easily prove, like if A is a general matrix, let's say the elements are there and this is of the size m by n, then A square is this matrix times this matrix itself. So for this multiplication to be defined, this n has to be equal to m. So that means m equal to n. So this is a square matrix. So A square, and then again the further powers of A is defined if and only if A is a square matrix. You need to keep this point in mind. Now coming to some important definitions. You have to note these definitions. These are important. So we call a matrix A as idempotent matrix if the square of the matrix A is A itself. That means if we are to calculate A cube, it becomes A square times A. So A square matrix is A as per the definition of idempotent matrix. So this multiplication becomes A square. Now from the definition itself, it becomes simply A. So A to the power n is A, where n is greater than equal to 2. That means any higher power of A starting from n equal to 2 will always be equal to the A matrix itself. This you have to keep in mind. Now coming to the second important definition, that is involutory matrix. We call a matrix involutory matrix if the square of the matrix becomes the identity matrix. And similarly, we call a matrix nilpotent matrix if for some n belongs to the natural numbers and n is greater than equal to 2, that means n is not 1. So A is not null, but some higher power of A becomes null, null matrix or the zero matrix. Then we call this matrix A as nilpotent matrix, and this n for which A to the power n is null matrix, this n we call the order of nilpotency. This we have to remember. Now coming to orthogonal matrices. If A multiplied by its transpose matrix becomes the identity matrix. Now this IN is basically the nth order identity matrix. Here n is the order of matrix A. Now note that these definitions are true only for square matrices. So the order of the square matrix A is n by n. So if A into A transpose is identity matrix, then we call that matrix A as orthogonal matrix. Now coming to this question, this was asked in JEE Main 2024. It says that let A is this matrix. If the sum of the diagonal elements of A to the power 13 is 3 to the power n, then n is equal to, and then we have to give the answer in the blank space. Basically, we have to calculate some higher powers of A. That means we have to first calculate A square. So A square will be A times A. So this will be 2 minus 1, 1, 1. So if we multiply this 2, it becomes 4 minus 1, so 3, minus 2 minus 1, so minus 3, 2 plus 1, so 3, then minus 1 plus 1, so 0. Now if we calculate A to the power 4, it becomes A square times A square. So now from this relation we can take the 3 common, so it becomes 3 times this matrix. So we can multiply the constants overall outside the matrix multiplication. So this will be 3 times 1 minus 1, 1, 0 times 3, then 1 minus 1, 1, 0. So these two we can multiply individually. So it becomes 3 square, so 9. Then multiplying these matrices will give us 1 minus 1, so 0, then minus 1, then 1, then minus 1. Similarly, we can calculate A to the power 6. It will be equal to A to the power 4 times A square. So it will be 9 into A square is 3. So we multiply the scalars outside independently and then multiply the matrices individually. So it becomes A to the power 4 is 0, minus 1, 1, minus 1. And it is multiplied with 1, minus 1, 1, 0. This becomes 27 times the multiplication will give us 0 minus 1. So minus 1, then 0, then 1 minus 1, so 0, and then again minus 1. That means minus 27 times this 1, 0, 0, 1. Now this is an identity matrix. So we can write this like this, minus 27i. Now this A to the power 13, we can write this matrix as A to the power 6 multiplied with A to the power 7. So we need to calculate A to the power 7 for that. So A to the power 7 is equal to A to the power 6 multiplied by A. This becomes A to the power 6 is minus 27i and multiplied with A. Now I times A is A because I is the identity matrix. So this becomes minus 27a. So if we multiply these two matrices, it becomes A to the power 13 is equal to A to the power 6 times A to the power 7. So it is equal to minus 27 times minus 27 times I into A. So here it becomes 3 to the power 6, as we are to report the answer in power of 3. So we wrote this in this form: 3 to the power 6 times a, because I into a is a. So this becomes 3 to the power 6 times 2 minus 1, 1, 1. Now you can see simply that this matrix becomes 2 into 3 to the power 6, then minus 3 to the power 6, then 3 to the power 6, then again 3 to the power 6. So the sum of the diagonal elements, that is the sum of the principal diagonal elements in this matrix, becomes simply 2 plus 1 times 3 to the power 6. This is the sum, or we define this as the trace of this matrix. So trace of a to the power 13 is equal to this. This becomes 3 to the power 7. So our n is equal to 7. That means 7 will be the correct answer for this question. I hope you understood this question. I have given some more PYQs on this concept. You need to try them yourself. So this question you have to try it yourself. Now coming to the next topic, that is matrix operations. Let A is this matrix. So this is the general representation of any matrix A. Then we define the operation transpose as A transpose is A dash ij with the size n by m. So when we are going to transpose, let's say this matrix 2 3 4, then 1 2 1, it is of the size 3 by 2. We are going to write this matrix like this. If we are looking from this side 2 1, so we write this as 2 1 from this side. Similarly here 3 2 becomes 3 2, and then 4 1 becomes 4 1. So this is the transpose of this matrix. So you can easily see that the size of this matrix is 2 by 3. So here it is written the same. So the element ij in new matrix becomes the element ji of the old matrix. You can easily see from here. For example, this element corresponds to the, let's say this matrix is A. So this element is A. Then this is the second row and the second column. So this is A22. Now here this element becomes this. Now you see, if we interchange the row and the column, so 2 2 becomes 2 2 itself. So here also the second row and the second column element becomes a dash 2 2, which is equal to a22, because I is equal to j. So when I is equal to j, the position remains unchanged. So if you apply these conditions given here for a square matrix, you can say that the principal diagonal elements of the square matrix remains unchanged upon performing the transpose operation. So here are the important properties to remember. This is a very important section. You have to remember the properties in your tips. So the first property, if A is a square matrix and A transpose is A, then A has to be a symmetric matrix. So from this definition, we can see easily why this holds true. A transpose becomes equal to A. That means this A dash ij, let us omit this dash. That means Aij is equal to Aji. Upon performing the transpose operation, we get this, and this is equal to Aji. So it is the definition of symmetric matrix. You can see from the earlier slides we saw. Similarly, if A transpose is minus A, then it is called a skew symmetric matrix. You can also prove this by the method we already discussed. Now coming to the second property, you can distribute the transpose operation over addition or similarly subtraction. And for distributing this transpose operation over products, you need to simply reverse the order of the matrices. So this point is very much important because if you forget the reversal of the order, you may get a wrong answer. So be careful. And if we take the determinant of the transpose matrix, the determinant value will be the same as the determinant value of the original matrix. So you need to keep these points in mind. Let us solve a question from JEE Main 2024. It says that A is a square matrix such that A transpose is equal to identity matrix. Now from here, can you tell which type of matrix is this? Yeah, it is orthogonal matrix. Now we know that the square of the matrix is denoted by the multiplication of the matrix with itself. So we have to multiply this matrix with itself and then plus A minus A transpose multiplied by itself. So if we calculate this product, it becomes, now be careful, we need to multiply this with this, then this with this, then with this, and then this with this. So you cannot directly open the brackets without multiplying them in order. It becomes A into A, so A square plus A into A transpose. So A into A transpose is given to us as identity matrix. We write it here. And then A transpose into A. So we write it like this. Then A transpose into A transpose. So A transpose square. Plus you can similarly multiply these two. It becomes A square minus I minus A transpose A plus A transpose square. So here these two gets cancelled. These two also get cancelled. So we are left with half times A square plus A square. So 2A square plus 2A transpose square. That means it becomes, if we cancel the 2, A into A square, so A cube plus A into A transpose square. Now we can write this product as A cube plus A into A transpose into A transpose. Now A into A transpose is given to us as I, and I into A transpose is A transpose itself. So we can write this expression as A cube plus A transpose. So this is our correct option. So the option corresponding to the correct answer in this case will be option number 4. I hope you understood this question. Now coming to a very important point. This is a very important point. If A is a square matrix of size 3 by 3, then trace of A into A transpose is equal to trace of A transpose into A is equal to sum of squares of all the elements of matrix A. So this is written as A11 square plus A12 square plus A13 square plus so on up to A33 square. This result you need to keep in mind because this particular concept is repeated in many questions of JEE Main and JEE Advanced. So you need to keep it in your tips. So let us solve this question based on the concept that we just discussed. It was asked in JEE Advanced 2017 and you can see similar questions in JEE Main 2021 and JEE Main 2022. Here I am going to solve this question and you have to try the rest of the questions yourself. It says how many 3 by 3 matrices M with entries from this set are there for which the sum of the diagonal entries of M transpose times M is 5. So here sum of the diagonal entries means trace of M transpose M is equal to 5. So if we assume M to be the matrix A, B, C, D, E, F, G, H, I, then we can simply say that trace of M transpose M will be equal to A square plus B square plus C square plus D square plus E square plus F square plus G square plus H square plus I square. It is equal to 5. Now, as all the elements belong to this set only, that means their squares, A squares, B square, C square, and so on up to I square will belong to the set 0, 1, 4. So we have to somehow arrange these terms such that their sum equals 5. So we have to consider cases. Let us take the case 1 when we take here 4 ones and not 4, 5 ones and rest of the elements are 0. So that means 4 zeros. Then we will get 5. So in how many ways we can do that? We can do it by 9 factorial divided by 5 factorial, 4 factorial ways. Now consider case 2. If we take 1 4 and 1 1 and rest of the entries are 0, that means 7 zeros. In how many ways we can do that? We can do it by 9 factorial over 7 factorial ways. There are no case possible for this question. Now here it will be 9C4, so it becomes 9 into 8 into 7 into 6 divided by 4 factorial, that is 24. So it becomes 7 to the 14 times 9, so it becomes 126. And similarly it is equal to 9 into 8, so it is equal to 72. And the total number of ways, that is total number of matrices M with entries from this set. So we can write total number of matrices is equal to simply the sum of the number of ways of these two cases. That means it becomes 126 plus 72. So 8 and 1 9. So 198 is the correct answer. That means option B is the correct option. I hope you understood this question. Now you have to try this question from JEE Main 2021 with similar concept. Just here the set is different and the trace value is different. So you have to try it yourself and match the answers given in the slides. Here also the set and the trace value is different, and here also answer is given. Now let us proceed to the next topic. Here is the second operation, that is adjoint of a matrix. So adjoint we define as the transpose of cofactor matrix of any matrix A. So adjoint A we define A cofactor and we take the transpose of this matrix A cofactor to get adjoint A. Now cofactor matrix of A has elements Cij, where every Cij can be calculated from this formula. So here Mij is the minor of element Aij. Now what is a minor? For example, if you are taking a 3 by 3 matrix like this, then the minor of any element, say this element, how to calculate this? You have to simply not consider the row that the element is in and the column where the element is, and then calculate the determinant of the rest of the matrix. That means if we have to calculate the minor of this element, by the way, if we denote this matrix as A, this element is A23. That means if we are to calculate M23, it becomes minor of element A23, so it becomes determinant of 1 1 3 1. So it will be equal to 1 minus 3, so minus 2. This is how we calculate the minors. And for this cofactor, we can determine C23 by minus 1 whole to the power 2 plus 3. So 5, then Mij is minus 2. So it will be simply minus 1 times minus 2. That means it is equal to 2. So the cofactor of element A23 will be 2. This is how you are to calculate the minors and cofactors. Now here is an example given for you. You can calculate the minor and cofactors and then calculate the adjoint A. Here you can do it by yourself. Then we come to the properties. This is very much important. So this property in particular is very much important. You have to keep in mind that A times adjoint of A is determinant of A times the identity matrix of order n, where A is a square matrix of order n. This is very much important. Now, coming to the other properties, adjoint of A transpose is adjoint of A whole transpose. So, the transpose and the adjoint can be interchanged. Also, adjoint of AB is adjoint of B times adjoint of A. So here the reversal law is applied as same as the transpose. Here also adjoint and inverse of a matrix are interchangeable. So keep these points in mind. Now we come to the determinant. Determinant of a matrix is defined only when the matrix is square matrix. So if A is square matrix of nth order, determinant of A we write either by this notation or by this notation. You can use any of them. This determinant is this. So if A matrix is say 2 3 1 2 is a 2 by 2 matrix, square matrix of order 2, then determinant of A will be 2 3 1 2, this determinant, and the determinant value will be this minus this. So 4 minus 3 is 1. Now coming to the properties, determinant of Ka is k to the power n times determinant of A, where n is the order of matrix A. So determinant goes like this. If here is k, 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 k times the respective elements of this determinant, then if you want to pull out all the k's outside, then you need to pull out the k from any of the rows or any of the columns. So if you pull out all the k's from the first column, you get k times this becomes this, and then k, 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 k. Similarly, if you pull out all the k's from this column, you will again get a k, so k square, and if you pull out this 2, this becomes k cube. So this property you have to keep in mind. So we just saw that for a 3 by 3 determinant, you can say that determinant of k times all the elements is k to the power 3 times determinant of rest of the elements. And determinant can be distributed over multiplication but cannot be distributed over addition or subtraction. Now this property is very important because questions have been directly asked on this property. You need to keep this property in your tips. Here adjoint of adjoint of adjoint of adjoint of so on of adjoint A, this whole matrix, and then we take the determinant, then this determinant is equal to determinant of A to the power n minus 1 whole to the power k. So that means if we are to calculate adjoint of adjoint A, the determinant of this matrix, then it will be simply determinant of A whole to the power, let's say A is a nth order square matrix. So then determinant of A whole to the power n minus 1 raised to the power. Now how many adjoints are there? There are two adjoints. So it will be n minus 1 whole square. Like for example, for n equal to 3, this will be determinant of A raised to the power 3 minus 1 is 2, 2 square. So determinant of A whole to the power 4. This you need to keep in mind. Here comes a question of JEE Main 2024. Let A and B be two square matrices of order 3 such that determinant of A is 3 and determinant of B is 2. Then this whole determinant value is asked. So according to the property of determinant, we can distribute this whole determinant to determinant of all the matrices here. So it will be equal to determinant of A transpose times determinant of A times determinant of adjoint of 2A and the inverse of this, and then determinant of adjoint of 4B times determinant of adjoint of AB and then its inverse, then determinant of A and then determinant of A transpose. We can write this expression in this form. That means A transpose determinant will be same as determinant of A, and here also determinant of A transpose will be same as determinant of A. So here are total 1, 2, 3, 4 determinant of A. That means determinant of A whole to the power 4 times determinant of adjoint to A whole inverse. Now we know determinant of inverse of any matrix is equal to 1 over determinant of A. So it will be simply equal to 1 over adjoint of 2A determinant and times adjoint of 4B and determinant, and this will also be 1 over determinant of adjoint of AB. So this is multiplied with this. Now determinant of A whole to the power 4 is known to us times 1 over, now adjoint of some matrix determinant. Now if A is a 3 by 3 matrix, then 2A will also be a 3 by 3 matrix. That means the determinant of adjoint of this 3 by 3 matrix will be simply determinant of 2A whole square, because we know determinant of adjoint M is equal to determinant of M whole to the power n minus 1 raised to the power 1, because there is only one adjoint. So when n equal to 3, this determinant will be equal to determinant of M whole square. That means determinant of 2A whole square times, similarly we can calculate this, it will be by the same rule, determinant of 4B whole square. And now this we can split this adjoint as adjoint of B times adjoint of A. Now the determinant can also be splitted here over multiplication. So determinant of adjoint B becomes determinant of B whole square, then determinant of A whole square. So this we can write this determinant of A square will be left there, and if we calculate these determinants, this is of the form determinant of Ka. So as n is 3, that's the order of A and B matrices. So this will be equal to determinant of A square, this, and then 1 over, if I pull out this 2, it becomes 2 cube, but there is a whole square. So it becomes 2 to the power 6 into determinant of A whole square times, this becomes 4 cube and raised to the power 2. So this becomes 4 to the power 6 times determinant of B square divided by determinant of B square. So these get cancelled, these get cancelled. This becomes 2 to the power 6, which is equal to 64. So our correct option in this question will be option 1. I hope you understood this question. Now you can similarly solve this question. It is of the similar form. I have mentioned the answer here. It is also a JEE Main 2024 PYQ. You have to try it yourself. Now here is also a question of determinant. Let us solve this. So here A is this matrix, B is this, C is A, B, A transpose, and X is this. Then determinant of X is asked. So from the property of determinant, we can say if we take determinant of this matrix, it becomes determinant of A transpose times determinant of C square times determinant of A. Now these two are same, so it becomes determinant of A square times determinant of C square becomes determinant C whole square, because you can write C square as C into C and then split the determinant, so it becomes determinant of C square. Now we have to calculate the determinant of C for this. So C is given to us, so determinant of C will be simply determinant of A times determinant of B times determinant of A transpose. That means these two are same, so determinant of A square times determinant of B. Now what is determinant of A? Determinant of A is simply, you calculate the determinant, 2 plus 1, so 3. Determinant of B is simply 1. So the determinant of X becomes determinant of A square times determinant C whole square. So determinant of A whole to the power 4 times determinant of B whole square. Now this will be equal to determinant of A whole to the power 6 determinant of B square. That means determinant of A is 3, 3 to the power 6. Now if you calculate it, it becomes 729. So option 2 is the correct option. I hope you understood this question. Now this is a similar question asked in JEE Main 2024. You have to try it yourself. Now we need to take a closer look at determinants. You need to keep in mind that determinant becomes 0 when at least two rows become identical, or at least two columns of the determinant become identical. And also you have to keep these properties in mind, that you can add or subtract any row to any other row in the determinant, but keep in mind that any one of the rows has to remain unchanged during the process. So you cannot simultaneously change all the three rows together. And similarly, it is also true for columns. So here in this example, we added this row with second row and subtracted the second row from the third row to get this determinant. Also note this point, if any of the rows or columns of a delta, that is the determinant, is all 0, then the determinant itself is 0. And if A is a skew symmetric matrix of odd order, then determinant of A has to be 0. You can simply prove that by using the definition of a skew symmetric matrix. So we know for a skew symmetric matrix, A transpose is equal to minus A. If we take determinant both side, that means determinant of A transpose becomes determinant of A. It is equal to, as this is a minus 1 times A, so this becomes minus 1 whole to the power n determinant of A. Now if n is odd, then minus 1 whole to the power n becomes minus 1. So you can pull this determinant of A to the left side. So this becomes 2 determinant of A becomes 0. That means determinant of A should be 0. This you can prove by this method. Now coming to the topic, differentiation of determinants. If delta is this, then to calculate delta dash, you have to simply differentiate one row or one column of the determinant at a time. So here first we differentiate the first row and keep the rest of the determinant same. Then we differentiate the second row and then we differentiate the third row. And then we simply add all of this. This is the differentiation of this determinant. And for summation of determinants, you can apply summation operator, that is the sigma operator, if only one row or only one column of the determinant is variable. Like this, let's say you have to calculate summation dr, where dr is this determinant 1, 2, 3, then r 3, 4, then r square, then n, then 0. So you can directly apply sigma operator here. Then this sigma will go to the variable row because only this row is variable. So that means this becomes determinant summation 1, summation r square, and the rest of the determinant remains same. So you need to keep this point in mind. Now here is a question from JEE Main 2024. It says that if fx is this determinant, then 1 by 5 f dash 0 we have to calculate. You can directly differentiate this determinant by the rule we just saw, or you can simplify this determinant to expand it and then calculate fx and then f dash x at x equal to 0. You can go by any of the methods. So if we simplify this determinant first, let us go by second method. It becomes, if we simplify this determinant, now here I am saying that if I subtract r2 from r1, a 0 is created here, and also some constant terms will be created here. And also if I subtract the second row from the third row, again 0 will be created here, and then some constant terms will be created here. So I choose the operation r1 goes to r1 minus r2 and r3 goes to r3 minus r2. So it becomes minus 3, 0, 3. Then this row remains unchanged. Now I simply prefer to denote the cos to the power 4x as c to the power 4 because of simplicity, and sine to the power 4 x as h to the power 4. So this will be 3 plus 2 c to the power 4, then 2 h to the power 4, and then this will be h square of 2x. So this row becomes minus 3, then 3, then 0. Now here 0 is created in this determinant, so you can directly expand this determinant. This will be equal to, if we expand this determinant by this column, this will be plus minus plus minus plus. So this term we don't have to care about. This will be minus sign, so minus sign to the power 2 into 2x times this will be minus 9, then plus 3 into 9 plus 6 cos to the power 4x minus, so again will be plus 6 sine to the power 4x. This becomes 9 sine square 2x plus 27 plus 18 cos to the power 4x plus 18 sine to the power 4x. Now this you can write as 4 sine square x cos square x. So this you can write as 27 plus 18 we take common, and then cos to the power 4x plus sine to the power 4x plus this becomes 36 sine square x cos square x. So we can write 2 cos square x sine square x. Now this is nothing but cos square x plus sine square x whole square. So this becomes 1. So the determinant value, that is fx, comes out to be 27 plus 18. Now as fx is a constant function, the derivative of fx will be 0. So at any point the derivative will be 0. So option 1 will be the correct option. I hope you understood this question. Now you can solve this question yourself. You have to simplify this determinant and then you will reach your desired answer. Now coming to inverse. What is inverse? If A is a square matrix of order n, then A times A inverse is same as A inverse times A, which is equal to the identity matrix. So A inverse is defined as 1 over determinant of A times adjoint of A, if and only if determinant of A is non-zero. So the inverse of every matrix does not exist. Inverse of a matrix exists when determinant of that matrix is non-zero. If the determinant is 0, then we call the matrix as singular matrix because it has no inverse. So in that meaning it has to be singular. And when the determinant of this matrix is non-zero, the matrix is accompanied by its inverse. So it is called a non-singular matrix. So this is the trick to remember these terms. Now coming to the properties. Division of a matrix by any matrix A is not defined. Instead, we have to multiply by A inverse if it exists. And determinant of A inverse is 1 over determinant of A, as we saw in a problem. And transpose of A inverse is equal to A transpose and then inverse of A transpose. So inverse and transpose are interchangeable. Now an important property. If AB is null matrix, it does not imply that A is null matrix or B is null matrix. Like in normal algebra, if we are given that AB is 0, then we can definitely say that either of A or B is equal to 0. But in case of matrix algebra, we cannot directly say that. It may be a particular case when either of A or B is null matrix, but we cannot say in general that it has to be true. But note a point that if AB equal to null matrix and determinant of B is non-zero, that means AB equal to null matrix and B is a non-singular matrix, then A has to be the null matrix. I have given the proof of this. You can try the proof yourself and then you can check your proof with the given proof. Then we come to the topic system of linear equations. This is very important for JEE Main and JEE Advanced both, because you can expect at least one question in your paper for both JEE Main and JEE Advanced from this topic. Consider n linear equations with n variables. So system of linear equations is defined like this. Here there are n variables x1, x2, x3, so on up to xn, and there are n coefficients of n variables in each equation. So there are altogether n equations and you need to solve these n variables. Now these n linear equations we generally express in this form. This matrix is called the coefficient matrix A, and this is the matrix containing all the variables, and this is the matrix B, which contains the right hand sides of the n equations. So a system can be expressed in this form: A multiplied by x is equal to B. Remember that A is a matrix, X is a matrix, and B is also a matrix. Now there are two methods to find solutions. One is Cramer's rule and second is matrix inverse method. So Cramer's rule applies determinants and matrix inverse method applies matrices. Now there are some terms to note before going to the discussion of Cramer's rule and matrix inverse method. You need to keep in mind what is a consistency of a system. A system is consistent when it has some solutions. It may have unique solution or it may have infinitely many solutions. And if the system is inconsistent, it has no solution. Similarly, a homogeneous system is a system where the B matrix, that is this matrix in the right hand side of this system, this is equal to this matrix. That means all the elements of B matrix becomes 0. So we can take the example x plus y plus z equal to 0, then 2x plus 3y plus 4z is 0, then x minus y minus z is 0. We can take this example. It is example of a homogeneous system in 3 variables. And non-homogeneous system is a system which is not homogeneous. So there may be some finite number here, like 1, minus 1, in any of them. Now you have to note this point that for homogeneous systems, putting all variables equal to 0 will always give a solution. This is called a trivial solution. So for 3 variables x equal to y equal to z equal to 0 is called a trivial solution. Now in JEE syllabus, our scope is limited till n equal to 3. That means we have to solve at most 3 variables. Now the cases for no solution, infinitely many solutions and unique solution are demonstrated over here. You can visualize these diagrams in 3D. Like for no solution, there are no common points or common lines where these 3 planes meet. So there is no solution. And for infinite solutions, 3 planes meet in a common line. And for unique solution, 3 planes meet at a common point. So you need to keep this in mind. Now coming to Cramer's rule. We discuss this Cramer's rule for n equal to 3, that is for 3 variables. If ax equal to b is a system, then delta is called the coefficient determinant, which is equal to the determinant of the coefficient matrix. So here for three variables, this will be determinant a11, then a12, a13, then a21, a22, a23, then a31, a32, a33. So there will be two cases if delta is 0 and delta is non-zero. So if delta is 0, there is an unique solution. So for three variables, this will be equal to x equal to delta 1 by delta, y equal to delta 2 by delta, z equal to delta 3 by delta, where this delta 1, delta 2, delta 3 is obtained by replacing the rth column in delta by b. So delta is this determinant. We have to simply replace the rth column by the matrix B. So B is B1, B2, B3 for three variables. So in this example, we have to simply, let's say x3, the third variable in this equation is z. So if we want to calculate delta 3, that you can also denote by delta z also for simplicity. So delta 3 will be calculated by simply replacing this column by B1, B2, B3. So in this case, B1, B2, B3, and then this will be equal to delta 3. Similarly, you can calculate for x and y also. Now, when delta is 0, that is the coefficient determinant gives us 0 value, then there are two possibilities: no solution or infinitely many solutions. So, if any of the delta 1, delta 2, delta 3 is non-zero in case of a three variable system, then there is no solution for the overall system. And similarly, if delta 1 equal to delta 2 equal to delta 3 equal to 0, then there are infinitely many solutions. You have to keep these cases in mind because questions are directly asked based on these concepts. Now coming to matrix inverse method. We discussed this for n equal to 3. If ax equal to b, then x is a inverse b. Basically, here we multiply both sides of this equation by a inverse if a inverse exists. If determinant of a is non-zero. So we pre-multiply both sides by a inverse. That means a inverse ax is a inverse b. Now we know a inverse a is I. So I times x is x. So x is a inverse b. So this you can write like this, and then we take the cases determinant of a is non-zero and determinant of a is 0. If determinant of a is non-zero, then there is unique solution. Then you have to simply multiply these two matrices, and then by the equality of matrices you can determine the values of the variables. And when determinant of a is 0, that means a is not invertible. There are two possibilities: no solutions or infinitely many solutions. Then how to check? There are two conditions written here. If adjoint of A times B is null matrix, then there are infinitely many solutions. And if adjoint of A times B, this matrix is not a null matrix, then there are no solutions. You have to keep this in mind. Generally, Cramer's rule is most important from the perspective of JEE because questions can be directly solved from the Cramer's rule. You will have to hardly use this matrix inverse method to solve questions. Now, this question was asked in JEE Main 2024 from the topic of system of equations. Here it says, if the system of equations this has a non-trivial solution, then alpha belonging to open 0 to pi by 2 is equal to, and alpha is to be determined. So here it is a homogeneous system. So we can say that it always has a trivial solution 0, 0, 0. Now, for it to have a non-trivial solution, we must have infinitely many solutions for this system, because that is the only case possible where it can have more than one solutions. So we have to simply put the coefficient determinant equal to 0, because you can calculate delta 1, delta 2 equal to delta 3. They all will come out to be 0, because when you will replace the columns with this 0, 0, 0, then you will only get delta 1, delta 2, delta 3 equal to 0. Now for delta equal to 0, we simply put this determinant, that is the coefficient determinant. It becomes 1 cos alpha sin alpha, then 1 sin alpha minus cos alpha equal to 0. Now if we expand this determinant, it becomes 1 times minus cos square alpha minus sin square alpha. So minus, if we take common, then it becomes cos square alpha plus sin square alpha. So 1 with a negative sign. That means minus 1, then minus for this element, then root 2 sin alpha times minus cos alpha minus sin alpha plus root 2 cos alpha times sin alpha minus cos alpha equal to 0. That means if we open up, it becomes minus 1 minus root 2 sin alpha cos alpha with a positive sign here, of course, then plus root 2 sin square alpha, then plus root 2 cos alpha sin alpha minus root 2 cos square alpha is equal to 0. Now here you can take this cos square alpha minus sin square alpha as cos 2 alpha, so it will become root 2 times cos 2 alpha with a negative sign, then plus 2 root 2 sin alpha cos alpha, so it is equal to root 2 sin 2 alpha with a positive sign, minus 1 equal to 0. So from here we can say that root 2 times cos of 2 alpha plus sine of 2 alpha is minus 1. So if we take this here, it becomes this. So if we multiply both sides by 1 by root 2, this is simply cos of 2 alpha minus pi by 4 is equal to minus half. Now this corresponds to the solution 2 alpha minus pi by 4 equal to, I am not talking about the general solution, I am talking about a particular solution, that is equal to 2 pi by 3. So in this case alpha will be 2 pi by 3 plus pi by 4 divided by 2. So this becomes pi by 3 plus pi by 8. That means 11 pi divided by 24. So option 4 will be the correct option. I hope you understood this question. I have given some PYQs of JEE Main 2024 for your practice. Answers are also mentioned here in the slides. You have to solve them yourselves. Now coming to a important point, that is Cayley-Hamilton Theorem. Now note, this theorem is not in JEE syllabus, but some of the results are helpful in solving questions in a faster and more efficient way. The Cayley-Hamilton theorem says that every square matrix satisfies its own characteristic equation. Now, how to determine characteristic equation? Characteristic equation is to be simply determined by this relation. Determinant of A minus lambda I equal to 0, where the identity matrix is of the order as same as the order of A. Now, you need to remember the characteristic equation for a 2 by 2 square matrix and 3 by 3 square matrix. Here, the characteristic equation of 2 by 2 matrix is lambda square minus trace of A times lambda plus determinant of A times I is 0. And for 3 by 3 matrix, lambda cube minus trace of A times lambda square plus summation of minors of diagonal elements times lambda minus determinant of A times I equal to 0. If lambda 1 and lambda 2 are the roots of this equation, that means by the theory of equations we can say lambda 1 plus lambda 2 equal to trace of the matrix A, and lambda 1 lambda 2 is determinant of A. Similarly, here we can also say that if lambda 1, lambda 2 and lambda 3 are the roots of the characteristic equation, then their sum is simply trace of A and their product is simply determinant of A. Let us take an example. Let A is this matrix. If A cube equal to 4A square minus A minus 21I, where I is the identity matrix of order 3 by 3, then 2A plus 3B is equal to, and 4 options are given. This question was asked in JEE Main 2024. Now here, this is the matrix polynomial given. So here the polynomial is A cube minus 4A square plus A plus 21I equal to 0. Now as A satisfies this equation, we can say that this is the characteristic equation of A. So from here we can easily determine trace of A and determinant of A. So trace of A is minus this coefficient divided by 1. So trace of A is 4 from the theory of equations. And similarly, determinant of A is equal to minus 21. Now from here we get trace of A, which is 2 plus 3 plus B. So B plus 5 is equal to 4. That means B equal to minus 1. And from here we get 2A0, 1, 3, 1, 0, 5 and B is minus 1. This determinant is equal to minus 21. That means if we expand this determinant, 2 times minus 3 minus 5, so minus 8, minus A times minus 1 is equal to minus 21. That means A equal to minus 21 plus 16. It is equal to minus 5. That means A is minus 5. So we determined A to be minus 5 and B to be minus 1. So 2A plus 3B is minus 10 plus minus 3. So the answer is minus 13. See how fast we could determine the values of A and B from the concept of Cayley-Hamilton theorem. So this theorem you should always keep in your mind for faster solving. Now this question we already discussed. You should try this question by Cayley-Hamilton theorem. It will be faster. You have to try it yourself. Similarly, these questions are given here for your practice. You have to solve these questions after completely revising this chapter. So this was all from my side. Thank you, and do subscribe our channel for more JEE related content like this. Wish you all the best.